So far in all the previous videos, we've looked at you firing the cannonball vertically upwards, and we've also looked at you and your dad sitting in a car traveling horizontally. So we've looked at vertical motion and we've looked at horizontal motion. But now, what happens when you fire a cannonball at an angle? So when you fire a cannonball, it will travel something like this. You see, this motion here is really complicated. So what you do, when you have a diagonal motion, like let's say you fire a cannonball at 80 meters per second at an angle of 72 degrees. So you can simplify this as this. Hang on, fire it at 80. So this length is 80. This is 72 here. You can then use trigonometry to break this down. You see, when you fire it at an angle, it's really complicated to see what's going on. So you break it up as a vertical component here and a horizontal component here. So when something is traveling diagonally, you break it up into two components. So this here becomes one problem. So we're going to solve one problem like this, and then later problem two would be solving it as you and your dad sitting in a car here, and problem one would be you firing the cannonball vertically upwards. You see what I mean later. Okay, let's. In one of the earlier videos, I said that if you give a snooker ball a horizontal speed here, and the second ball you drop it vertically downwards, the two would be at the same height. Okay, I've done a video on this already, but then a similar thing happens when you fire a cannonball diagonally. So when you fire a cannonball diagonally here, you see, you firing the cannonball, even though it's moving in vertically and horizontally. If you just look at the horizontal component here matches up with the height of the cannonball. So if you fire, let's look at the cannonball here. If you fire a cannonball vertically upwards, it will travel like this, really fast at first, and then slows down to its maximum height, and then it will free fall back down to earth. Now, if you just look at the horizontal component here, this matches up with this, and this matches up with this, and this matches up with this, and when it gets to its maximum height, it's the same as when the cannonball here gets to its maximum height. And then on the way down, it will be here, this will matches up with this. On the way down here, this matches up with this, and here this matches up with this. So what I'm trying to say is that when you have something like this, if you fire it at 80, let's say this is 80 here, at an angle of 72, break this down as a vertical component here. So you want to know this length here. Well, this length here is the same as you doing this. Right angle here, okay? It's you working out this x here. So by using trigonometry, we can work out x. So the sun will be here. Now, if you don't understand this trigonometry part, then you have to watch you have to watch the trigonometry section. So the sun is here, the sea is here, and this here would be a sign to heaven. So this here would be a sign. This here, you get a suntan. You're lying on the beach, you get a suntan. This here would be a cord jumping out of the water, so it's cos. Okay, so this x here would be hang on, let me think. Sine 72 equals x over the hypotenuse, which is 80. Okay, now times both sides by 80, so you have 80 sine 72 equals x. So the vertical component here will be 80 sine 72. Okay, so hang on, let me do this again. So when you are firing a cannonball at 80, this is 80 here, at an angle of 72 here, break it up into its vertical component here. So this vertical component here well, you would imagine this right angle triangle here. This vertical component here would be 80 sine 72. Okay, and then you can use trigonometry again to break this down as 80 cos 72. So you see, you firing the cannonball here at 80 at an angle of 72 is the same as me visualizing me firing the cannonball vertically upwards at 80 sine 72. So if well, this here matches up with this here matches up with this. Don't worry about it too much. Just watch to the end of the video, and then I will give you an example, and then it will make sense. But at the moment, there's a lot going on here. Now, so when you fire a cannonball diagonally, you break it up into two problems. One here, this is problem one, where we've looked it up, where we visualize it as firing the cannonball vertically upwards. Problem two would be to look at you and your dad sitting in a car here. Remember, the horizontal component here is 80 cos 72. So you can imagine your dad traveling at a speed of 80 cos 72. So you see, this here matches up with your dad's car being here, and this here matches up with this. This here matches up with this. But by the way, it's just badly drawn. But all these the gap here, they're all the same. It's just like you imagine your dad's traveling at 7 meters per second. Then this gap here would be 7. This here would be 7. This here would be 7. This here would be 7, 7, 7, 7. This here is just a number. So all these gaps will be the same. It's just badly drawn. Okay. So my point is that your dad is traveling at a constant speed of 80 cos 72. So this your dad's car here matches up with this bit here. Your dad's car being here matches up with this here. Your dad's car here matches up with this. This matches up with this. This matches up with this, and so on. So if you want to know the range here, you break it up into a vertical component and a horizontal component. So to answer this question here, let's say your enemy is 500 meters away. You could use this technique to find out if you could hit your enemy when you fire the cannonball at 80 meters per second at an angle of 72 degrees. In the next video, I will give you an example. But the point of this video is that I just want to illustrate that you in order to analyze this, you have to break it up into a vertical component and a horizontal component. Visualize this as one problem, and then look at it, and then visualize this as a second problem, and then later we can combine the two to answer this question here. So in the next video, I will give you an example, and then you see what I mean.